Right, today we're going to find the area of a triangle using sine. So as usual, make some notes. Area of a triangle, heading, lesson objective, keywords and dates in Welsh, all underlined. So what I want you to do now is hit pause, make your notes, and when you're ready to move on, hit play again. And we move on to our starter for the day. So 3 questions. As usual, what I want you to do is hit pause now, attempt the questions, and when you're ready to go over them, hit play again. Right, so this question here, first things first, keyword, estimate. So estimate means we're going to round to one significant figure. 580 to one significant figure. If you look here, the 8 affects the 5, so that becomes 600. Times 0.218. The 1 does not affect the 2, so that stays as 0.2. Divided by one significant figure. Check. 8 does not. It does affect the 1, so that becomes 0.02. On the top, if you multiply 600 by 0.2, it's equivalent to 60 times 2, because I've multiplied this side by 10 and divided that side by 10, so that's 120 divided by 0.02. Don't like to divide by a decimal, so I'm going to multiply the denominator by 100 to make it a whole number. I've got to multiply the numerator by 100. So that gives me 12,000 divided by 2. If I halve 12,000, I get 6,000. Okay. Moving on to question 2. Find the volume of this shape. When I look at this shape, first it looks a bit complicated. Then I look at the front face. Now the front face is, what shape is that? Because if I can find the area of the front face, all I need to do is multiply it by the length, which is 3. So that's the cross-sectional area because it runs through the whole shape. Front face is a it's a trapezium. So if I say area is equal to sum of the opposite sides, A add B, A plus B divided by 2 times the perpendicular height, which gives us 8 plus 12 over 2 times the perpendicular height, which is 5. So that's 20 over 2 times 5. Half of 20 is 10. 10 times 5 gives me 50 centimeters squared. So that's the area. The volume is equal to the cross-sectional area times the perpendicular, the length of this funny shape. So times L be 50 times the length of 3. 150 centimeters cubed. To find this question, I'm given a formula, v squared here equals u squared plus 2as. This is used for final, initial and distances when you do mechanics or physics. You do mechanics at A level or physics. I think you've probably done this in physics now. Now if we go through each of these terms in turn, v, it tells us v is the final velocity. There you go, final velocity v, and it tells us the final velocity is 20, so that's equal to 20 meters per second. You can write it like that. The next term is u, that's the initial velocity, it tells us that in the question. Initial velocity is u, and that's given by 12 meters per second. A is the acceleration, which we don't know. So question mark for A. And S is the distance traveled. And the distance traveled in this case is 10 meters. So using the formula, if we write it out here, see what we can do. We have v squared equals u squared plus 2as. And if we put all the terms that we know in, put everything in. So v is 20 squared equals u is 12. So 12 squared plus 2 times a we are looking for times s, which is 10. So let's calculate those. 20 squared, 400, is equal to 12 squared, 144, plus 2 times 10, which is 20a, which is what we're looking for. So I can use my float and ping and carry that over the equal sign. Once it crosses the equal sign, it becomes minus. So I've got 400 minus 144 equals 20a. 400 take away 144 is 256 equals 20a. And I take that down the escalator, the 20 down the escalator. So 256 divided by 20 is equal to a. Now, is there a common number that goes into the numerator and denominator to simplify it? I think 4 goes here 5 times. 4 goes into 256. Into 25 is 6, carry 1, and into 16 is 4. So that means a is equal to 64 over 5. I can simplify that further, because 5 goes into 64 12 times with 4 remainder. So 4/5 is 0.8, so 12.8, and it's meters per second squared this time. Okay. You can also write it as they do in the question, 12.8 meters, and then they use a slash per second squared, or over second squared. Okay, good. So what I want you to do now is make corrections. So if you made any mistakes, then write the solution in full, show your workings. And so hit pause, make your corrections. When you're ready, hit play, and we move on to the next section. Right, so in the past, whenever we've been finding the area of a triangle, we've always used the same formula. Let's just remind ourselves of that then. Area of a triangle, we normally write A is equal to base times height over 2. And we've used that, you've used that for many years. And it's fine if we have a right angle triangle or we know the perpendicular height of the triangle. Otherwise, we can use this formula. A is equal to half AB sine C. We use this for any triangle, regardless of if it's right angle or if we know the perpendicular height. All we need to know are 2 sides and the angle in between, the included angle. So what's crucial about this is labeling. If we label our triangles correctly, then we have no issue. Now we're looking for sine C, so that's got to be C, which is in between 2 sides. Then we can label the other sides as we wish. Remember capital letters for the angle, and then small letters for the sides, which are opposite the angle. So that's going to be B, opposite B. This is going to be A, and this is going to be C. So our formula, A is equal to 1 over 2 AB sine C. And all we do now is we just fill in the numbers. So it's 1 over 2 times A is 6 times B is 5 times sine of 63 degrees. And you put that straight into the calculator, exactly as it is. Don't change it, don't do anything to it. Just put it in the calculator like that. And you should get 13.4. Centimeters squared. And it says that's simple. Let's try this one here. Again, we've got 2 sides and the angle in between. So if we label that angle in between C, we can call this side A and call this side B. And we can label the sides as well. Opposite A will be small a, opposite B, small b, and opposite C, small c. So labeling is crucial. Again, always write the formula. Area equals 1 over 2 of A, B, sine C. We're always writing the formula. We don't need to be able to prove the formula at this stage. So if we fill in the numbers, 1 over 2, A is given by 8.5 times B, 10.1, times sine of the angle in between those two lines, so 25. And if I work it out on my calculator, what do you get? You get 18.1 centimeters squared. So you might want to try this one on your own, have a go, and when you're ready to have a look at the solution, hit play. Right, always with these, write the formula. So the area is equal to half AB sine C, and we always, sine, the C is the angle in between, so that's going to be C. Labeling, this can be A and this can be B, doesn't really matter. Opposite A is small a for the side, opposite B is small b, opposite C is small c. So let's fill in what we know. A half times A is 12.3 times B is 9.1 times sine of the angle in between, which is 130. Plug that into your calculator and you should get 42.9. Oops, 42.9. Units are in meters, so meters squared. Job done. So you might want to make some notes, sketch the diagrams, label the sides, and then write the solutions. Off you go. Hit pause. When you're ready to have a go at the next 3 questions, hit play again. Okay, so I think you're able to tackle this one on your own. So hit pause, attempt all 3. When you're ready to go over the solutions, hit play again. Right, as usual, most important thing is labeling the sides. This is the angle, which is in between the 2 sides, so this is going to be C. This can be A, and this can be B. A and B are not important. Opposite A, got small a, opposite B, got small b, and opposite C, got small c. Right, now formula, A is equal to a half AB sine C, the angle in between, equals a half times 6.1, which is A, times 7, which is B, times sine of 78. Plug it into your calculator and you should get 20.9 centimeters squared. Let's look at question 2. Again, labeling is important. That's the angle in between A and B. Opposite A is small a, opposite B is small b, and small c here. So A is equal to a half AB sine C, which is a half, times A, 10.2, times B, 13, times sine of the angle in between. Plug it into your calculator, work it out. You should get 65.3 centimeters squared. As for the third, same thing again. C, A, B. There's our triangle labelled. That's side B. That's side A, that's side C, which we're not going to use. So there's our formula. Plug in the numbers we have. A half times A, 12.3, times B, 7.1, times sine, 118. And once we plug it into our calculator, we should get 38.6, and the units are in meters, so it's going to be meters squared. Okay, so hopefully you've marked those. Hopefully they all worked out to one decimal place. And we'll move on. 2 questions here. Your turn to have a go. Hit pause. Have a go at them. When you're ready to look at the solutions, hit play. Now then, we're working in a circle, but we want to find the area of the triangles OAB or AOB in the circle. They've given us one of the sides there and the angle, but we need 2 sides. What about, they've given us OB, what's OA? It's also going to be 8 centimeters, correct? And why? Because it's a radius. So OA and OB are identical. So that means, what kind of a triangle is that? Isosceles. Correct. Area is equal to half AB sine C, which is a half times A. That center there is going to be C in this case. So opposite A is A, opposite B is B. So it'll be 8 times 8 sine of the angle in between, which is 100. Work that out on my calculator. Gives me 31.5. So that's 31.5 here. Centimeters squared. Similarly here, we call that C. We've got A and B, so that's small a, that's small b, that's small c, the side opposite angle C. Write our formula. And we work through it then. A half times A is 6.3 times B is also 6.3 because it's an isosceles triangle, times sine of 83.6, the angle in between. Work it out in your calculator, you should get 19.7 centimeters squared. Good, so make some notes, and when you're ready, then it's time to do some questions. And finally, what you've been looking forward to, some questions for you. So off you go, good luck. And I'm going to attach these to the assignment as well.